Dink a dink a doo, a dink a dink a doo, a dink a dink a dink a dink a dink a dink a doo, ba-doo. The Atwood machine was invented in 1784 by Reverend George Atwood as a lab experiment to verify the mechanical laws of motion with constant acceleration. So, with that said, can you guess what we are going to talk about this week? Yes, you got it. The main objective of this week's lab is to demonstrate that if a system has a fixed total mass, the ratio of the net force and the acceleration will be constant. Busting out the F equals ma. Oh, yeah.
So the cool things you'll be using: a pulley, a photo gate, that's your Atwood machine, hanging masses, and data studio.
Okay, so in a slippery world without friction, an ideal pulley may exist. An ideal pulley would be frictionless and massless, and the only function that it would have was to redirect a massless string in one dimension from one way to the other way. That's it. But seeing that we don't live in a slippery world, well, okay, with this in mind, we can see that the Atwood's machine is driven by an external force. Magic! No, 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 no. This force is equal to the difference between the two weights. Say that M1 is bigger than M2, the external F external will equal M1 minus M2 times G, the acceleration due to gravity. Now, we enter into the real world, that means friction. Because we are all amazing scientists, we will account for friction in this week's lab. Okay? There's also a mass of the pulley that we have to account for that introduces a small amount of rotational inertia, but we will neglect that for this week. Please just remove that from your mind. So when we talk about this amount of real-world friction in our equation of motion for F external, we have to say that F external minus the friction force due to the pulley is equal to M1 plus M2 times the acceleration of the masses. Okay? Because we want to account for the total masses, that's why our masses are added. Okay, so we can rearrange our equation so that we put the friction force on the other side with the mass and the acceleration. And then if we were to graph this equation of F external versus acceleration, we would get a straight line, we should get a straight line, that has a slope of the total mass and an intercept of the friction force. So this week's lab, you're going to use the Atwood machine to measure the acceleration of the masses as they move from one side of the machine to the other. Then you're going to calculate the external force for each run. It's not that bad. Then, by graphing your measured acceleration and your calculated force, you'll be able to compare that slope to the expected slope of the total masses of your system. Then you're gonna, that's it. That's it. So that's the Atwood Machine Lab. Yeah. Have fun. Make sure you don't let things fall on the ground. Okay, bye.